So we've seen that cars are actually remarkably efficient. If you work out how much energy a car actually uses to get to Sydney, it's not very different from what it would theoretically need to use. So there's no real room to improve cars by more than 50%. I mean, that's going to keep automotive engineers working on the 50% for the next many decades. They're not out of work. But it makes us wonder, is there some more radical way we could do it to actually get cars that are, let's say, 10 times better than we've got at the moment? Well, how can we do this? Well, remember the energy is going into overcoming rolling resistance, and it's coming into overcoming drag, wind resistance. It's also being wasted because of the heat engine efficiency. Now, because these two are pretty much the same, improving one, let's say we manage to completely get rid of rolling resistance. Let's say we had a hover car or maglev car or something, so there's no wheels at all. They're still not going to give us a factor of 10 improvement. Even though the rolling resistance might have dropped by a factor of 1,000,000, it's only half of the energy loss. The other half is a drag. So you're still going to have to do something about the drag, otherwise you're never going to get more than a factor of 2. Even if you get rid of both of these, however, you're then going to drop down to the starting stopping energy and the hill energy, which is 2 orders of magnitude smaller. So that will get you a factor of 100. What that's telling is it's a difficult situation when you've got two things that contribute equally. You have to get both of them down. Getting just one of them down will only give you at most a factor of 2, no matter how much you reduce it. So what could we do? There are a few possibilities. One possibility would be, as I said, to not have wheels, to have magnetic levitation. And then that gets rid of this. Then to get rid of drag, maybe instead of driving down a road, we can put the cars inside a pipe and pump the air out, get a vacuum pump. So there's no air to travel through, and you're magnetically levitating along inside a capsule. And that way your energy consumption will be very, very small. And in fact, that's the Hyperloop concept, currently under development. The idea is you actually have cylinders, you fire capsules down it as a super high-speed train. That's going to be very expensive. You need to have all these cylinders. You can't just drive around and get to your car or on home or anything like that. How else can we do it? Well, we could reduce rolling resistance by pumping up your tyres properly. But better still would be if you had, say, steel wheels. If you have a steel wheel, you probably go on a steel track to be able to withstand the intense pressure. That would drop your rolling resistance by quite a lot, maybe a factor of 10. Then to get rid of drag, maybe what we need is enormously elongated cars. Maybe we'd have a car that can take 1,000 people but is only as wide as a normal car, so you get lots and lots of seats all the way along. And we'll have it running on metal wheels along a metal track. And of course we've seen that before. It's called a train. That's, for example, how the bullet train or TGV works. You have an area, cross-sectional area that's not much bigger than a car, have enormously long and thin, so you can fit more people in, and you run on steel. So that can be quite a bit more efficient. How about heat engines? What can you do for that? Well, you need to either not use the heat engine, so if you're using something like battery power, that gives you an enormous advantage. The drawback is the amount of energy you can store in a kilogram of battery is much less than the energy you can store in a kilogram of petrol. So you're going to need a lot of batteries, a huge amount of weight, so your car's going to get much heavier because of all the weight of the batteries in it. And even then, you've got rid of the heat engine loss. That gives you about a factor of 2 improvement, which is certainly worth having, but not a factor of 10. And it doesn't really give you that factor of 2 improvement unless the electricity you're using to charge your batteries came from some efficient source. And most electricity comes from power stations that are themselves heat engines and no more than 50-60% efficient. So, it's going to be hard. There is no easy way to make something that looks like a car drastically more efficient than current cars. So I think there's a real reason why we've not seen the 10 million-fold improvement in cars that we've seen in computers. There are ways forward, but they don't look very much like cars anymore.